Hey everyone, ready for another deep dive? Today we're going to be tackling transformers and attention
Oh,
mechanisms.
yeah.
You know, the stuff that helps AI understand language in a way that it never really has before.
Right.
Um, and it's almost like giving AI the ability to focus,
Yeah.
just like you would at a loud cocktail party trying to have a conversation.
Right.
You tune everything else out and focus on the person you're talking to.
Mm-hmm.
And that's kind of what attention mechanisms do for AI.
Yeah.
Our source material for this deep dive is an excerpt from a new book that's coming out soon called What Everyone Should Know About the Rise of AI.
Oh, wow.
And
I'm looking forward to reading that.
yeah, me too. Me
Yeah.
too. It's pretty mind-blowing stuff, I have to say.
Yeah.
But yeah, we're going to break it down for you today and hopefully give you a clear understanding of how these powerful AI tools actually work.
That sounds good.
So to kick things off, maybe you can just give us a quick overview of how transformers have really revolutionized natural language processing.
Sure. So, before Transformers came along, AI models, they were kind of like robots reading dictionaries. They could, recognize individual words,
Right.
but they struggled to grasp the nuances, the context, the real meaning behind those words.
It's like they were missing the forest for the trees.
Exactly. Yeah. They were very focused on the individual pieces, but not so much on the big picture.
Yeah.
But then Transformers came along and really changed the game.
How so?
Well, they use these things called attention blocks,
Okay.
which allow the AI to zero in on what's truly important,
Mm-hmm.
in a sentence, in a paragraph, even in an entire document.
So it's like they have this superpower to filter out the noise and focus on the signal.
Exactly.
Okay.
And that's really crucial for tasks like machine translation, for example.
Okay.
Imagine trying to translate a complex sentence from English to, say, Japanese.
Yeah.
Without understanding the context, the relationships between words, you'd end up with a jumbled mess.
It'd be like trying to assemble furniture with only half the instructions.
Uh-huh.
Uh-huh.
That's a perfect analogy.
Right.
But with attention mechanisms, the AI can actually grasp the subtleties of the original language and produce a translation that captures the true meaning,
Yeah.
the nuances, the feeling, even of the text.
Wow. So it's not just a word-for-word translation.
No.
It's actually trying to understand the meaning behind the words.
Exactly.
That's impressive.
Yeah.
So how does it actually work? What's going on under the hood?
All right, so let's get a little technical here.
Okay.
It all starts with something called embeddings.
Embeddings.
Essentially, it's a way to represent a word as a set of numbers,
Oh, okay.
like a unique fingerprint that captures its essence.
So each word gets its own numerical code.
Exactly. And
Right.
that code captures, its meaning, its relationship to other words.
I see.
But then the question is, how does the AI use that to understand the relationships between words?
Right, because just having a code for each word doesn't mean you understand how they work together.
Exactly. And that's where it gets really interesting.
Okay.
That's where matrix operations come in.
Matrix operations.
Yeah.
All right. I'm following along.
These are the mathematical engine behind attention mechanisms.
Okay.
Think of it like this. You have these things called query, key, and value matrices.
Query, key, and value.
Yeah, the queries is like the AI asking, what information am I looking for?
Okay.
The key is like the text saying, here's what I have to offer.
So it's like a matchmaking service for words.
Uh-huh. Yeah, that's a great way to put it.
Right.
And through some clever calculations between these matrices,
Mm-hmm.
the attention mechanism figures out which words are most relevant to each other,
Okay.
which ones should be linked together to understand the overall meaning.
So it's not just looking for individual words, it's figuring out how they connect, how they dance together to create meaning.
Exactly.
Yeah.
And that's how it can decipher things like sentiment, for example,
Sentiment.
like whether a piece of text is positive, negative, or neutral.
Oh.
Not just by looking for specific words,
Right.
but by understanding how those words are used in the context of the entire sentence.
So it's like the AI is reading between the lines,
Mm-hmm.
picking up on those subtle cues that we humans use to convey emotion.
Exactly. But there's another brilliant aspect to attention mechanisms.
Okay, what's that?
They're incredibly good at maintaining the integrity of the original text.
What do you mean by that?
Well, it's not just about picking out the important words.
Yeah.
It's about understanding them in the order they appear.
Oh, right.
So it's not just jumbling things up.
So that's crucial for something like document summarization, right?
Absolutely.
Like if you're trying to summarize a long legal document or something.
Yeah, you need to condense the information,
Right.
but preserve the original meaning, the sequence of events, the logical flow.
You don't want to mix up the cause and effect.
Exactly. And attention mechanisms ensure that the information flows in the right direction.
Okay.
They keep things organized and prevent later parts of the text from influencing the meaning of earlier parts.
This is fascinating.
Yeah.
Like the AI has this built-in sense of order, a way to keep everything straight.
Mm-hmm. And here's where it gets even more sophisticated.
Oh, boy.
Transformers use something called weighted sums
Weighted sums.
to refine those embeddings we talked about earlier.
Okay. I'm all ears.
So imagine you're studying for an exam and you're highlighting the key points in your textbook.
Yeah.
Some points you might highlight with a bright yellow highlighter because they're super important.
Right.
Others maybe get a lighter shade because they provide context.
Uh-huh.
But they're not the main ideas.
Yeah.
Weighted sums do something similar in AI.
So it's like the AI is highlighting the most relevant information.
Exactly.
Giving more weight to the words that carry the most meaning.
You got it.
Okay.
And this helps optimize the model's understanding of the context,
Makes sense.
making it even more accurate and efficient.
So how does this play out in like a real-world application?
Well, think of question answering systems.
Okay.
You ask a question,
Uh-huh.
and the AI needs to find the answer in a massive database.
Right.
Weighted sums help the model zero in on the key information, ignore the irrelevant parts.
So it's like having a super efficient research assistant
Right.
who knows exactly where to look for the answer.
Precisely. And that's because it has this incredible ability to understand the context, the relationships between words,
Yeah.
and the relative importance of different pieces of information.
This is mind-blowing. It's like the AI is developing a depth understanding of language, almost like a human.
It is remarkable how far we've come with this technology.
Yeah.
And there's so much more to explore.
I bet.
We haven't even touched on concepts like self-attention and multi-headed attention.
Well, hold that thought. I'm definitely eager to learn more about those.
Okay.
But first, I think our listeners would appreciate a little recap of what we've covered so far.
Sure.
We've talked about how transformers use attention blocks to decode, meaning how embeddings and matrix operations work, and how weighted sums help refine the AI's understanding of context.
Yes. And we've also seen how this technology is being applied in real-world applications like machine translation, sentiment analysis, and question answering systems.
Right. And you're saying this is just the tip of the iceberg.
Believe me, this is just the beginning.
Wow.
There's so much more to come.
I can't wait to dive deeper into the more advanced concepts in part 2 of this deep dive.
All right. Sounds good.
But for now, let's leave it there, and we'll pick up where we left off next time.
Okay.
See you then.
Sounds good.
Welcome back. Still with me. I'm still trying to wrap my head around all this talk about embeddings and weighted sums.
That's a lot to take in.
It is. But hey, it's fascinating stuff.
It really is.
So, remember that cliffhanger we left you with?
Oh, yeah.
Self-attention.
Right.
What is that all about? It sounds kind of like some AI meditation technique.
Uh-huh. Well, it's not quite meditation,
Okay.
but it does involve the AI kind of looking inward, analyzing the relationships between words within a single piece of text.
So instead of looking outward to the wider context, it's focusing on the internal connections.
Precisely. Imagine you're reading a novel
Okay.
and you come across a pronoun like he.
Yeah.
Self-attention helps the AI figure out which character he refers to
Oh, okay.
by analyzing the surrounding sentences.
That's clever. It's like the AI is playing detective,
Right?
using context clues to solve the pronoun puzzle.
Exactly. And this ability is crucial for tasks like named entity recognition.
Named entity recognition.
Yeah, where the AI needs to identify things like people, organizations, or locations in the text.
So it's not just about understanding individual words,
Right.
but also recognizing patterns and relationships that reveal deeper meaning.
Exactly. Self-attention allows the AI to grasp the who's who and the what's what within a text,
Okay.
which is incredibly valuable for things like information extraction and knowledge organization.
It's like the AI is creating a mental map of the text, highlighting the key players and their roles.
Now, how does this differ from cross-attention,
Oh, yeah.
which we touched upon earlier? Remember that one involves connecting different types of data.
Right. It's like comparing apples and oranges. Is that, or in this case, text and images?
Imagine you're building an AI system that can generate descriptions for images.
Okay.
Cross-attention would allow the AI to analyze how the visual elements in the image relate to the words it wants to use in the description.
Gotcha. So self-attention is like an internal dialogue within a single data type,
Right.
while cross-attention is a conversation between different data types.
A brilliant way to put it. Each type of attention plays a crucial role in helping AI understand and process information in all its complexity.
This is getting seriously mind-bending.
Oh, no, right.
But hold on, we haven't even reached the peak of attention mountain yet.
What do you mean?
There's something even more powerful called multi-headed attention.
Ah, yes. This is where things get truly fascinating.
Lay it on me.
Multi-headed attention is like having a team of expert detectives,
Okay.
each focusing on a different aspect of the text.
So it's like a brainstorming session where each detective brings their unique perspective to the table.
Exactly. Each attention head, in a model like GPT-3, looks for different patterns and connections within the text.
Uh-huh.
Some might focus on grammatical structure, while others might analyze semantic relationships.
So by combining the insights from all these different heads, GPT-3 builds an incredibly rich and nuanced understanding of the text.
Precisely. And this is one of the key reasons why GPT-3 is so good at generating human-quality text.
Wow.
It can capture subtle nuances and variations in meaning that previous models simply couldn't.
It's like GPT-3 has this incredible ability to read between the lines,
Mm.
to grasp the subtext and the implied meanings.
And that's what makes it so powerful for tasks like creative writing, chatbot interactions, and even code generation.
Wow. It's like we're witnessing the birth of a new kind of intelligence.
It's really something.
One that can understand and manipulate language with astonishing fluency.
It's certainly a remarkable achievement, and it has profound implications for the future of AI.
Speaking of the future, our source material hints at a world where AI can interpret nuances reason across vast data sets and potentially even surpass human capabilities in certain areas.
It's a bold vision,
It is.
and one that raises many questions about the role of AI in society.
Yeah, definitely something to ponder.
Absolutely.
But before we get lost in those philosophical rabbit holes,
Okay.
let's take a moment to appreciate the ingenuity of the attention mechanism itself.
It's a testament to human creativity
It really is.
and our ability to understand and replicate the complexities of our own minds.
And who knows what other breakthroughs await us as we continue to explore the vast landscape of AI. Perhaps attention mechanisms are just the first step towards a future where humans and machines collaborate to create something truly extraordinary.
It's an exciting time to be alive, that's for sure.
It is. This deep dive has been an incredible journey into the heart of AI. I feel like we've peeled back the layers of this complex technology and gained a deeper appreciation for its power and potential.
I agree.
But our exploration isn't over yet. There's still much more to uncover as we delve into the practical implementation of attention mechanisms and their impact on real-world applications.
This is the so what factor.
Exactly. Stay tuned for part 3, where we'll explore how these amazing concepts are being used to power everything from language translation to medical diagnosis. Welcome back to the final part of our deep dive.
The grand finale.
Yeah. We've explored, the inner workings of transformers and attention mechanisms.
Right, all the nuts and bolts.
Yeah, from embeddings to multi-headed attention. It's been quite a journey.
It has.
But now let's shift gears a bit and see how these powerful concepts are actually being implemented in the real world.
Right, the so what.
Yeah, the rubber meets the road.
Exactly.
So, it's fascinating how these things that once seemed like very abstract mathematical concepts are now actually driving some of the most innovative AI applications that we see today.
It's really amazing to see theory come to life.
It is. It is.
And one of the most remarkable applications, I think, is in neural machine translation,
Oh, yeah.
which has seen a significant leap forward thanks to attention mechanisms.
You mean like services like Google Translate?
Exactly like that, yeah.
Which I use all the time, by the way.
Yeah, a lot of people do.
It's amazing.
And, before attention mechanisms, machine translation was often pretty clunky,
Yeah.
especially with complex sentences.
Right.
But now, thanks to the AI's ability to understand context and relationships between words,
Mm-hmm.
translations are becoming much more accurate and natural sounding.
So can I finally trust those online translators to handle like my important international emails?
Well, I wouldn't say they're perfect yet, but they've come a long way.
Okay.
And the beauty of the attention mechanism is that it's incredibly efficient
Okay.
and it can be parallelized.
Parallelize. What does that mean?
meaning it can process large amounts of text data very quickly.
Oh, okay. So it's like having a team of superpowered translators all working simultaneously.
That's a great way to put it.
Right.
And the speed is crucial for real-time translation services.
Yeah.
Like those used for live captions or international conferences.
It's amazing how this technology is breaking down language barriers and connecting people across cultures.
It really is a beautiful thing.
It is. It is. But, the applications go far beyond just translation.
Right.
I've heard that attention mechanisms are also being used in fields like medicine
Yes.
to analyze patient data and even assist with diagnoses.
Absolutely.
That sounds incredibly promising.
It is.
Can you give us an example of how that works?
Sure. So imagine an AI system that can analyze a patient's entire medical history,
Wow.
their lab results, the latest medical research,
Right.
to help doctors identify potential health risks or make more accurate diagnoses.
Mm-hmm.
Attention mechanisms can help the AI focus on the most relevant information and identify subtle patterns that human doctors might miss.
That's incredible. It's like having a super intelligent medical consultant by your side.
It's like having an extra set of eyes
Yeah.
that never gets tired.
Right, exactly. It's still early days, of course.
Yeah.
But the potential for AI to really revolutionize healthcare is immense.
It's huge.
And you're saying attention mechanisms are a key part of making this vision a reality.
They are definitely one of the key drivers.
It's mind-blowing to think how these mathematical concepts
I know.
are having such a tangible impact on people's lives.
It's really amazing.
So I guess, the takeaway here is that it
Okay.
all goes back to the power of understanding language.
Right.
By being able to grasp the nuances of human communication,
Mm-hmm.
AI is opening up a world of possibilities.
It really is a game changer.
Yeah, and this deep dive, has given us just a glimpse into that world.
A peek behind the curtain.
Yeah, exactly. We've explored the intricate mechanisms that allow AI to process language, understand context, and make connections that, were once thought to be exclusive to the human mind.
It's incredible how far we've come.
It is. And, for you, our listener,
Yeah.
we hope this deep dive has sparked your curiosity and given you a solid foundation to engage with, all the ongoing conversations about AI and its implications.
Definitely, because this is just the beginning.
Yeah.
And it's important to stay informed, ask
Yeah.
questions,
Right.
and consider both the potential benefits and the ethical considerations of this technology.
Yeah, because the future of AI is being shaped right now.
Right now.
And it's up to all of us to ensure that it's a future that benefits humanity.
Couldn't agree more.
So keep learning, keep exploring, and keep diving deep into this fascinating world of artificial intelligence.
That's the key.
Well, that's all the time we have for today. Thanks for joining us on this journey.
It's been a pleasure.
Yeah, and we'll see you next time for another deep dive.